Let us talk a bit about the sine rule and the cosine rule. Now, this is a copy of a section from your formula sheet, list of formulas that you will find in paper 2 of the CSEC mathematics paper. Here we have a triangle and you have the sine rule. The length of the side A, let me just zoom in a bit. So what you have is the length of side A, which runs along here, small a, that's the length of the side A, divided by the sine of this angle A. So it's the length of the side A divided by this angle A, the sine of this angle A, is equal to the length of side B, that's this side here, divided by the sine of side B, of angle B I mean, and that is also equal to the length of C divided by the sine of angle big C. That's the sine rule. So it's basically the length of a side divided by the sine of the angle that is opposite to the side. The length of this side over the angle opposite to that, the sine of the angle opposite to that side, equals the length of the other side divided by the sine of the angle opposite to that side, equals the length of the third side divided by the sine of the angle opposite to that side. So that's what the sine rule is saying. Note that even though they have this height here, the right angle here, we consider the entire triangle ABC. Alright? Now note that the sine rule applies to all triangles, whether it's right angle triangle or not. But remember that the trig ratios, sine is opposite over hypotenuse, cos is adjacent over hypotenuse, tan is opposite over adjacent. Those apply only to right angle triangles. If it's not a right angle triangles, you can't use those. But with any triangle at all, you can use the sine rule. Then we have the cosine rule here, right? What the cosine rule says is that a squared, that's the length of a squared, is equal to the side B squared plus the next side C squared minus 2BC cosine of the angle A. Now that applies when you have A squared, starting with A squared. You could also apply it here, where you have B squared is equal to A squared plus C squared. Right, it's ABC, A squared plus C squared, minus 2 times A times C cos. Now notice that the side was squared here. Side A was squared and the cos of the angle A. Side B is squared here, so it's cos of the angle B, uppercase B, because this is side B and this is the angle B. Alright? And of course, it can apply where you look at the side C. C squared, you're calculating the side C, C squared is equal to A squared plus B squared. So you don't repeat the C's. A, remember, it's A, B, C. A, B, C is A, B, C. So for the squared part, you have the three sides squared. A C squared is equal to A squared plus B squared minus 2AB. Notice it's B squared plus C squared is 2BC. A squared plus C squared is 2AC. A squared plus B squared is 2AB. You don't know, in this case, you don't know what A is, so you cannot put 2 times A times C because you don't know what A is. That's what you're calculating, alright? Alright, so C squared is equal to A squared plus B squared minus 2AB cos C. Alright? Now, when you are given a triangle to work with, the thing is, any side can be A, any side can be B, any side can be C. Suppose, for example, you have this triangle here. Now, if you're going to be working out this side and you call it A, alright? This side is B, this side is C. You have this angle. You have two sides and the angle between them. You use the cosine rule to find the third side. If you know B and C, you just say A squared is equal to B squared plus C squared minus 2BC cosine of this angle would be uppercase A. Notice that this is side A, small a, this is angle A, big A. If this is side C, which is small c, then this would be angle C, which is big C. This here is side B, which is here, side B, which is small b, lowercase b. This angle would be angle B, which is uppercase B, big B. So that's what you have. So those are the sine rule and the cosine rule. You use them when you're dealing with a triangle, when you're dealing with triangles that are not right angled triangles. Now we're going to look at some examples, alright, but that's for our next video. So I'll see you in the next video.